Now we did a few questions based on how to handle simple concept of inserting geometric means between certain numbers. We did also questions based on how to, if given a condition that some number is a geometric mean of the other, what further values can be found out. Now we need to move over to the concept of sum of GP, that is sum of terms in a GP. Just to remind you, Sn is nothing but a into 1 minus r raised to n upon 1 minus r if r is less than 1, and the same Sn would be a into r raised to n minus 1 upon r minus 1 if r is greater than 1. And suppose it is an infinite series, that is, we want to find the sum of infinite terms and r is less than 1. That means as n gets closer and closer to infinity, r raised to n in such a case would tend to 0. So the same formula that is there in such a case would turn out to be a into 1 minus 0 upon 1 minus r, Sn, which ultimately would be a upon 1 minus r. So for an infinite series, especially when r is less than 1, then the sum is given to be a upon 1 minus r. So the same concepts we shall be using and see how we can apply this formulae, these three major formulae, in finding out whatever is the requirement of that particular situation. Okay. So here you have sum of the series 1 by root 3 plus 1 plus 3 by root 3 plus so and so 218 terms. So the first term a is going to be 1 upon root 3. R is going to be T2 upon T1, which is 1 divided by 1 by root 3, which is going to be 1 into root 3, that is root 3. So R is going to be root 3, which means R is greater than 1, which is root 3. And you need to find Tn. So Tn is what? Sorry, Sn has to be found out, not Tn. Sn we know we shall be using a into r raised to n minus 1, not 1 minus r raised to n, because r is greater than 1 upon 1 minus r. So a in this case is 1 upon root 3. R raised to n minus 1 is nothing but root 3 raised to 18 minus 1 upon, sorry, this is going to be r minus 1 upon root 3 minus 1. Now this will turn out to be 1 upon root 3. Root 3 raised to 18 is the same as 3 raised to 9 minus 1, which will be upon root 3 minus 1. Since it is root 3 minus 1, we can multiply both numerator and denominator by root 3 plus 1. We need to do that so that the denominator gets rationalized. This will now become 1 upon root 3 into, this will turn out to be 3 raised to 6, 7, so which turns out to be 1966.83 minus 1 upon root 3 minus 1 into root 3 plus 1 is root 3 the whole square minus 1 the whole square into root 3 plus 1, which will turn out to be 1 upon root 3 into 19682 and upon 3 minus 1 into root 3 plus 1, and this will turn out to be 1 upon root 3 into 19682 upon 2 into root 3 plus 1. This of course will turn out to be 9841. So ultimately it's going to be 9841 into root 3 plus 1 the whole upon root 3 is the sum of this geometric progression series till the 18th, for the first 18 terms. So it's 9841 into root 3 plus 1 upon root 3, or 1 plus root 3 upon root 3. So among these, this is the one which tallies with what we have, and definitely with confidence we can say that is what we have got it right. Furthermore, okay, now the sum of the first 20 terms of a GP is 244 times the sum of its first 10 terms. The common ratio is so and so. Sum of first 20 terms. So that is going to be S20 is equal to 244 times S10. So the common ratio is what? So S20 in that case would be A. We can use R raised to N or 1 minus R, because in this case we don't know whether R is greater than 1 or less than 1. But either ways, since the signs are going to interchange, so the value will remain the same. The net value will remain the same. We can take R raised to N minus 1, and it's going to be, here it is going to be R minus 1 is equal to 224 times A into R raised to N minus 1 upon R minus 1. Now A gets cancelled. In this case is going to be R raised to 10 minus 1 upon R minus 1 is equal to 224, 20 minus 1, I'm sorry, is going to be into R raised to 10 minus 1 upon R minus 1. This again gets cancelled. R raised to 20 minus 1 can be written as R raised to 10 square minus 1 upon R raised to 10 minus 1. The whole square is 224. So we are going to use A square minus B square. This will turn out to be R raised to 10 plus 1 into R raised to 10 minus 1 upon R raised to 10 minus 1 is equal to 224. So this gets 244. I'm so sorry, it has to be 244 everywhere. 244. This gets cancelled and you get R raised to 10 plus 1 is 244, which means R raised to 10 is 243, which means 243 is nothing but 3 raised to 5 is R raised to 10. But we need to make this thing equal, so R raised to 10 will turn out to be root 3 square plus or minus root 3 square the whole raised to 5, because 3 can be written as, we need to keep the indices the same. So R raised to 10 would be plus or minus root 3 raised to 10. So R raised to 10 is plus or minus root 3 raised to 10. We need to consider both plus and minus, because the geometric progression could start from the smallest term to the biggest term, or from the biggest term to the smallest term. So in such cases, we have to consider both positive and negative, and hence R will turn out to be plus or minus root 3. And hence, the common ratio is going to be root plus or minus root 3, which is going to be this. And yes, the correct option here is plus or minus root 3. Okay, here we have an interesting question. X is equal to 1 plus 1 by 3 plus 1 by 3 square plus dot dot dot, which means that both these are sum to infinity. That is, we are considering adding up of terms to infinity in such a case, and more so R is less than 1. If R is less than 1, so as n tends to infinity, R raised to n tends to 0. So Sn in such a case would be A upon 1 minus R. So if you see X is nothing but A in this case is 1 upon 1 minus r. R in this case is 1 by 3 by 1, 1 by 3, which will turn out to be 1 upon 3 minus 1, 2 by 3, which is 3 by 2. And y, which is the sum of 1 plus 1 by 4, again, would be using the same formula. We used it here. We are going to use the same formula here. A in this case is also 1, 1 upon 1 minus r in this case is 1 by 4 by 1, 1 minus 1 by 4, which will turn out to be 1 upon 3 by 4, which is nothing but 4 by 3. So in that case, xy would be 3 by 2 into 4 by 3. This gets cancelled and you get it as 2. So xy is 2. So we get xy as 2. Yes, and we do get xy as 2. So here we are using the concept, since in the previous questions was clearly told sum of 18 terms, 19 terms, 20 terms, we knew the value of n. In this case, since it's a clear-cut indication that it is a sum up to infinity. So hence we get xy as 2. Okay, now here we have sum of how many terms of the sequences 256, 128, 64, is 511. So which means A is 256, R, which is going to be T2 upon T1 or T3 upon T2, which is 128 by 256, which is turning out to be half, and Sn is 511, and we need to find n. Now we are going to use Sn is equal to A into 1 minus r raised to n upon 1 minus here. You need have to guess too hard why you're using this formula, because r is less than 1 in this case, so it's right to use this formula. So that means we substitute 511 instead of Sn. A is 256, 1 minus half raised to n upon 1 minus half, which will turn out to be 511 is equal to 256 upon 2 minus 1 half into 1 minus half raised to n. Right. So you have 511 is equal to 512 into 1 minus half raised to n. So that means this will turn out to be 511 upon 512 is equal to 1 minus half raised to n. So this will turn out to be 511 minus 512 minus 1 is equal to minus half raised to n. Remember, the minus is outside the bracket. It's not minus half the whole raised to n, minus of half. This on simplification will turn out to be minus 1 upon 512 upon is equal to minus, we can write it as 1 upon 2 raised to n itself, because 1 raised to n in any case is 1, minus gets cancelled. This will turn out to be 512 is equal to 1 upon 2 raised to 9. 2 raised to 9 is 512. So which means we have 2 raised to 9. So this we can write it as 2 raised to 9. This will remain 2 raised to n. So 2 raised to 9 is equal to, so we have 2 raised to 9 is equal to 2 raised to n, which means n is equal to 9. So, which means that 9 such numbers on adding will give 511. So we get this answer as 911. Right? We got it right.